Good evening, everyone. I am Sagar. I am pursuing mechanical engineering at IIT Delhi. So my project at MRC was calculation of sediment bearing pressure. My approach will be Biostol geoacoustic approach for this. Currently, there are two research approaches for the calculation of sediment bearing pressure. One is classical, which is accurate, that is the CPT testing method, but it is invasive to the sediment and is not scalable over the large areas. Another approach is the acoustic approach, which is scalable, but it is not accurate enough so that to get a defensible number or could be utilized in the production requirements. So sediment bearing pressure will be required for anything, if any offshore infrastructure is built on the seawater, any amphibious or logistical trafficability is needed. So and also it will be helpful for designing military strategies if we know we know the sediment bearing pressure for Indian Ocean region properly. Next is what my methodology, which I will be presenting, includes, and why is it different from others. So my goal was to pursuing the acoustic approach only, but increasing its accuracy such that it can be usable. So basically, for that, I included every environmental factor that would be affecting the sediment bearing pressure. Basically, seawater density and viscosity, which will be derived from the temperature, salinity, and depth. Also, sediments are always a mixture of many different components. So I tried to model the mixture properties as well. And also, there is another property that if carbonate percentage greater increases the 50%, then different methodology is used for the calculation of sediment pressure. So my approach also takes account of for that. And then the Hardin-Strain model calculates the dry frame pressure. And for the effective vertical stress, I'll be using the Athis compaction profile to calculate to integrate the vertical stress depending on the porosity of the seawater at that level. And finally, as a safety factor, we have two methods: Terzaghi-Mayarov basic method and Tezcan-Kesely methods for the calculation of sediment bearing pressure. And these are two independent methods. We'll be calculating by both of these with appropriate safety of factors, and we'll be using the one which have minimum value to ensure better accuracy. So here comes the methodology part. Basically, firstly, I will be taking the input, the maximum grain diameter, fines fraction, mineral mixture type, and the temperature, salinity, and depth of the seawater. Also, for the foundation case, we'll be using the foundation characteristics as well. Then comes the calculation of the fluid properties and grain solid. We will be using the Voigt reduced Hill method for mixed mineral moduli. Then frame with the then comes the calculation of the sigma v, that is effective vertical stress using the Athis compaction profile, and for the calculation of the moduli for the dry frame of the mixture of the sediments using the Hardin-Strain method. Then comes the main pipeline Bart-Stoll method, which converts the dry frame into the wet frame and gives us the shear velocity and V shear velocity and V compressor velocity VP. So the Tezcan-Kesely method takes Vs and gives the sediment bearing pressure. But in case of the Terzaghi method, we have another procedure, that is we need to calculate the stiffness factor, which is undrained shear stress SU, which it is calculated directly from the shear velocity that is coming out of the Bart-Stoll model. It is governed by a power law, the factors A and B. These are the constants which need to be calibrated by the site specific data. So my model also includes to be accurate, my model also includes that we need some CPT data, and such that by curve fitting we get the A and B parameters. And by the Thevenin fines and Bolton's method, we calculate the internal friction angle. Now these two values go to the Terzaghi-Mayarov basic method, and in my calculation part right now, I have assumed factor of safety here for 3, and in the Tezcan method as factor of safety for 4. So these two methods will be used for the calculation of sediment bearing pressure. So this is final methodology. I have one example of the calculation part where the mixture is mixed sand with 25% fines and water depth is 50 meter, and the calculation of sediment bearing pressure will be below 5 meter the seafloor, and the footing width is 2 cross 2 cross 2 cross 2 cross 1. So firstly, there is a linear bend that is, we are not accounting the mixture of the sediments, mixture properties of the sediments. And so it comes out to 77.7. For the after using my pipeline, the Terzaghi-Meyrov comes out to 65.9, and the Tescan-Caselli comes out to 46.5. So we will be using the minimum one, that is 46.5. So seeing the both the results, if we did not work on this and use the linear method, there will be a high certainty of failure at 77.7 kilopascal, since the appropriate sediment bearing pressure will be 46.5. That's why the accuracy is important for the sediment bearing pressure, and my approach includes the accuracy part as well. Nextly, for conclusion, the approach calculates the sediment bearing pressure from grains to completely to the end, and also gives us accurate enough answer to be used by the industrial works as well. Also, for the shallow Indian Ocean region, this can be easily configured with the some amount of CPT data and calibration of the A and B parameters. That's all. Thank you from my side.